The first step after opening up the new DVM Pro software is clicking on the Unit button and telling the software your desired units of measurement. After that, click on New to start a new DVM Pro project. A window will pop up where you'll be asked to enter your project name, your customer's name, and your information for this project. After that, select the country, state, and city of the project. If the project city is not an option, select the closest city to the project. The software will automatically provide the standard design conditions for that area. If necessary, this data can be edited. Once completed, click OK. At any point, we can click the Information button at the top and change any of the project information or design conditions. We need to tell the software how our building is set up. The standard setting is a building with one floor and a roof. If we click Edit on the bottom of the screen, we can add and modify floors in our building. The height is in inches, so I'm going to change it to 10 feet, and if I want to add a second floor, I'll select down below and I'll enter 2 for a second floor. Then I'll specify a floor height. At this point, I'll press Enter on my keyboard. So now I have 2 floors. If I want a third, I'll enter 3, 120-inch floor height, and Enter. At any point, I can go back and modify the floor height. So if my third floor is an 8-foot ceiling, I'll go back, select, and change to 96, and press Enter on my keyboard. At the top of the window, you'll see a little thumbtack icon. When you select this, you have the option to lock or auto-hide a window. Auto-hide will hide the window when your arrow is not in the area. It will reappear once you click on it again. To undo this feature, click on the thumbtack and select Lock Screen. At this point, the software sees our project as a single building, 3 floors, and a roof. If you need to add another building to a project, click on the blank page on the bottom and add as many buildings as necessary. You can rename each building by right-clicking and selecting Rename, or select it, right-click, and delete to remove. In the upper left-hand portion of the main window, you'll see the room information for the project. This is where we're going to add our indoor units. You can name each room or zone if you'd like, but you do not have to. So for this example, we'll start with Conference. Next zone, we'll call it Zone 2. I'll hit Enter, and I'll add one more. We'll call it Common Area. Zone and room names are not required, but if it is necessary, you must do it at this point. You'll see that it notes required capacity for each room. You can specify a required capacity of cooling and heating for each room or zone. So I'm going to put in a few capacities for this example so I can demonstrate what this will do for us. For this example, I'm not going to enter any required capacities for the common area zone. So now I'm going to select indoor units for each zone. So I'm going to click on the little gray box, and since I've specified required capacities, on the left-hand side, depending on the model type of indoor unit I click on, down below it'll specify a quantity for each capacity to meet or exceed the requirements for each zone. Once I decide which model and quantity I'd like to use, I'll click Add. It will then place those units in that zone and name them based on the zone name. Now for Zone 2, I'm going to click the gray box, and since I've specified a required capacity for this zone, depending on the model type of indoor unit I select on the left, down below the software will specify a quantity for each capacity of unit to meet the minimum requirements for that space. I will then click Add, and that quantity of indoor unit will be added to that zone. At any point, you can rename an indoor unit by double-clicking and then typing in the new name and pressing Enter. For the common area zone, I'll click on the little gray box to add indoor units. Since I have not specified a required capacity for this zone, I'll select the type and quantity of indoor unit on my own. If you need to revise an indoor unit type or capacity, select the unit, select the replacement type, and then click Modify. It will then change the unit up above in the main indoor unit list. If you need to remove a unit, select the unit or units you need to remove and click Delete on your keyboard, and the unit will be removed. We can now select accessories for our units, including wired controllers, panels, and condensate pumps. You can select unit by unit, or you can select multiple units at the same time by holding Shift or Control as you click. Once you've selected a unit or units, on the bottom, click Accessory and specify the panels, condensate pumps, or other components that you want on your project. Once complete, click Enter. Once a unit has additional components selected for it, an orange check mark will appear on that unit. If you do not specify panels for cassettes, they will not appear on the list of materials in the report. We now need to place our indoor units with an outdoor unit or units. You can select a single unit at a time, a handful of units at a time, or every single unit and place them on a single outdoor unit. To select more than one indoor unit at a time, use Shift or Control while clicking. We will then drag them down below to the outdoor unit list window on the bottom of the screen. Once the outdoor unit window appears, you'll see the indoor units placed on this system on the right-hand side. We now need to specify the type of equipment on this project. For this example, we'll select DVM +3 condensers. Once you've specified the condensing unit type, We need to tell the software our desired combination ratio. Samsung DVM systems design ratio can range from 50 to 130% design diversity. Based on the specified combination ratio, the window will present a number of options based on the combination ratio cooling and heating capacities. Specify which unit you want to use and click OK. On the main window, we can rename our condensing unit. Double-click, retype, and press Enter. After that, we need to place the condensing unit on the project. For this example, I'm going to put my outdoor unit on the ground level. If you need it on the roof, drag it up to the roof. I'm then going to specify an indoor unit, indoor units, or all units, and drag them over to the floor where they're going to be placed. If you accidentally place an indoor unit on an incorrect floor, go to the main indoor unit list, select that unit, and drag it to the appropriate floor. After all condensing units and indoor units have been placed in the building, the piping tab will become available. Once in the piping tab, you'll see your condensing unit. If you click here, you'll be able to scroll between multiple systems on projects that have more than one system. Since this system has 9 indoor units, I know that I need at least 2 mode change units. So I'll select a Y joint and drop it here. To zoom out, I'll click here and it'll pull the entire system. You can also zoom in and out with the wheel on your mouse, like on popular design and drafting software. Now I'm ready to place my mode change units. I'll select mode change unit and drag it over to one side of my Y joint. I'll then select an appropriate MCU. You can now start placing your indoor units on your system. You have the option of selecting one unit at a time and dragging it over, or selecting multiple units and dragging them over. Since I have 4 units left, I'm going to grab another mode change unit and drag it over to the other side of my Y joint. I'll select an MCU with 4 ports. I can now drag and drop my indoor units as necessary to this mode change unit. The numbers below each length of pipe represent the actual length, the equivalent length, and the number of elbows on that pipe. We can change this value later. After you've placed all your indoor units on the system, it's recommended that you do a piping check. This will make sure we haven't done anything that's not allowed by the system. After you select the check mark, the results of the pipe check will display on the bottom of the screen. After this step, we must go back and enter the piping length of every section of pipe on the system. To do this, select a section of pipe, and on the right-hand side of the screen, enter the actual piping length and the number of elbows on that section. We must go through and do this for every section of pipe on the system to ensure that we do not exceed any maximum piping limitations on this system. During this process, if you click on any indoor unit, on the right-hand side of the screen, information about that unit will be displayed. After you've entered all of the piping lengths, you need to go back and redo the piping check. The results of the pipe check will display at the bottom of the screen. You have the option of exporting this piping layout in a drawing file. You can save it to a file as an image, or you can print directly to your printer. Click here to run a capacity compensation. The software will take all the data we've entered so far and run a simulation and provide estimated capacity at each indoor unit. Piping lengths and the number of elbows can be modified later by selecting the section of pipe that needs changed and modifying the data. Make sure that if you do this, you go back and run another piping check and capacity simulation. The Wiring tab will display general, low voltage, and high voltage wiring information. If you click on a wire at any point in this diagram, it'll give you a basic description of what that wire is. Next to each unit, you'll find the main address, the RMC1 and the RMC2 address. You can modify this by clicking on an indoor unit and on the upper right-hand section of the screen, changing the main address, the RMC1 or the RMC2 number. Next to each MCU, you'll see the main address of the appropriate connected indoor units. Any changes made to the main address of a connected indoor unit will appear here on the appropriate MCU. The column number at the top of the screen will modify the appearance of the drawing. The next two boxes will allow us to label the indoor unit and the outdoor unit breakers. This may be required on larger commercial projects. The wiring drawing can be exported as a drawing file, an image file, or you can print it to a PDF or directly to a printer. In the Controller tab, we will lay out and design central control options. Not every option that is available globally is available in North America. All central control options require an interface module. We'll click here to select the type of interface module that we need to use. We'll select the yellow dot on the left-hand side of the interface module to connect it to our central control options. Click the orange arrows to move controllers around on the screen. The controller diagram will also note the connections of wires between each device. R1 and R2 to our DMS2, F1 and F2 from our condenser to our interface module. If you need to completely start over, click on the little broom button on the top of the screen. That will reset the drawing completely. If other controllers are required, click on the controller you want to connect to and click the yellow dot. On the left-hand side, select the component you'd like to connect to the system. Central control options allow for many systems to connect to a single controller. To specify this on the diagram, select the controller and then select a yellow dot to connect it to additional systems if present. After you've completely designed your system, you can generate a report with the software detailing simulated capacities, piping layouts, and other information. Click Report and specify where you'd like to save this file.